Hi, class. Today we are going to work on conditional proof, which is the totality of 3.3. So conditional proof, we're going to say a lot about it, obviously. But the most important thing I want to emphasize for now is it's just one new rule. We learn one rule this week, we learn one rule next week. Otherwise, nothing changes from exam 2. And that's really important because that means you're still going to need all your exam 2 skills to complete exam 3 and eventually for exam 4. So you've taken the exam, you should hopefully know how you did on it. Whatever you missed on exam 2, you need to get right. And so, yes, we're going to learn conditional proof today, but make sure you are buckling down and using any extra time this week to shore up any shortcomings you have on the 3.1, 3.2 material, because we're just building off of that. We're still going to use all those rules. We just add one more this week, one more next week. So what's conditional proof? Your book does a pretty good job explaining it. But one thing I'm kind of surprised by is that it doesn't actually give the general form. The general form, I think, is helpful because it tells you a few things. So treat these as whatever premises are before the proof. You assume P, lowercase, some finite number of steps, you get to Q. And then if P, then Q. So as sloppily as I did this, the indent is important. So this is a different indent than this. Because what we're doing is we are doing exactly one thing. Conditional proof, when done correctly, is simply a rule that builds horseshoes. That's it. Just in your mind, fix it as one extra rule that builds horseshoes, which means when do you use it? Not right away, but whenever you need to build a horseshoe. Thing 2 to remember is that is all it does. The only thing it does is build a horseshoe, and the horseshoe has to be of a specific form. Note these are lowercase. P is indented, again, as the book explains. You should have read the book before watching this. P is your assumption. That's why it's indented. You didn't prove P. You didn't prove this line, you didn't prove this line, you didn't prove this line, and you didn't prove Q. What you proved is that P leads to Q, or that P implies Q. So all these indented steps you don't know. Instead, you only know the one thing, if P, then Q. So the proof could keep going. You could keep doing more lines after this. And the reason these are indented, let's say this is line 1, 2, 3, 4, 5, 6, 7, 8. If I'm doing more work down here, let's say I need to change this if P then Q to not P or Q by implication. Business as usual. But what I can't do is something like Q or M by line 7 addition. No, 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 can't do it. That's why we indent and then we line it off when we've crossed off our assumption. This is an assumption. These are all things that are based on an assumption. So we can't use it. To use not really a concrete example, but a silly example, suppose I'm trying to prove that if Mickey is over 10 feet tall, then he is the tallest person in the room. Okay? Notice, and this just goes back to our truth table, this if-then is obviously true. There is no doubt that if Mickey is 10 feet tall, then he is the tallest person in the room. And yet, That's an if false, then false, or possibly an if false, then true. So if I am completing this proof, start by assuming Mickey is 10 feet tall. From that, prove he would be the tallest person in the room. You certainly don't know that Mickey is over 10 feet tall, and you certainly don't know he's the tallest person in the room. But what you can prove is if he was 10 feet tall, then he's the tallest person in the room. And then this line would say something like, Mickey's not over 10 feet tall, or he's the tallest person in the room, etc. And so the reason these are indented is we don't know any of them. They might be true, they might be false. We don't know because of the nature of horseshoes. All we know is that P leads to Q. That's all we're doing with the conditional proof. Let's shift from abstraction and tackle this with a real proof. So let's just go to that mild pain in the butt proof that was number 11 on page 107. It said, premise, Z and M implies is the case that S or A. Z implies not S. From this, it's supposed to follow that Z and not A implies not M. All right, we're looking at this proof again to emphasize that our method does not change. So I look at my conclusion. Does it occur in its entirety anywhere in a single premise? Nope. Which means I've got to build it. What type of statement is it? A horseshoe, a conditional. And so now, the only thing that's changed, now I have two rules that build horseshoes, and so I basically ask myself, does it look easier to do a hypothetical syllogism or conditional proof? Put another way, what I'll usually ask myself is, if I knew the antecedent, if I had the antecedent as an additional premise, would that make the proof easier? So, if I had a premise that said Z and not A, would that seem to make things easier? In that case, I'd say yes. So we assume it. So first of all, it's an assumption. I don't know this. I am assuming it. So Z and not A, that is an assumption for conditional proof. And sometimes I like to remind myself what I'm trying to prove. Because now, instead of trying to prove this whole conditional, I'm just trying to prove Q. In this case, I'm trying to prove not M. So you might as well treat this as your new conclusion. M is on the left side of a horseshoe, which means I'm going to have to modus tollens line 1. What would I need to modus tollens line 1? Not S or A. And now is enough to get started because, well, I could do it a few ways. But let's say, well, I could get not S right there. And I could get not A right there. And if you remember the problem from your worksheet, we can get this by De Morgan. So this is equivalent to not S and not A. So we'll get not S by itself, we'll get not A by itself. So, as I always say, I like to think of simp com simp as one move instead of three, just so I don't forget to do it. So I simp to Z, I com, line 3, and then I simp to not A. Got half of it. And what else do I need? Not S. Where does that occur in the premises? Right side of a horseshoe, which means I could do modus ponens with lines 2 and 4. I should be doing my double checks as always, but hopefully you're pretty solid on that by now, at least for a straightforward modus ponens. I then conjunction in the correct order, S and not, sorry, not S and not A, using 7 and 6 conjunction. because that's logically equivalent to what I need for modus tollens. Not one and not the other means neither by De Morgan. Now I can modus tollens line 1. So that becomes not the case. This is probably one worth doing our double check, just because it's a little more complicated. So theoretically, I should be able to modus tollens with lines 1 and 9. Let's check. Is line 1 of the form if P and Q where the main operator is a horseshoe? Yes. Is line 9 of the form not Q where it's a negation of everything after the horseshoe in line 1? Yes. I have confirmed I could do a modus tollens. Next step, turn my brain off. Write not P. I write a negation. I write everything before the horseshoe, including the parentheses. I've done 2 things. I learned something new, and I moved my M. Where's my M now? Inside a negation. The only thing we could do with the negation is De Morgan's. Becomes not Z or not M. What was it? Now it's in a disjunction, which means disjunctive syllogism. Can I? Yes, with one additional little double negation. Not Z. Line 4. And then not M for the pseudo win. That is using lines 11 and 12. Disjunctive syllogism. All right, and I got to here. And now conceptually, it's very important to think, why was I trying to get to there? What have I just shown? Have I shown that Z and not A is true? Of course not. Have I shown that Z is true? Of course not. I haven't shown that any of those are true. That's why they're all indented. What I've shown, that is unindented, what I've shown is one and only thing. I have shown that Z and not A leads to not M. And so I just write that. Z and not A. So my P has to be everything on the first assumption line. Then I write a horseshoe. Then I write Q, which is everything on the last assumption line, using lines 3 through 13, conditional proof. All right, you might say, well, 14-line proof is still messy. Yeah, but remember the original was 24. So there's actually 2 things to say about it. Conditional proof usually makes the proof shorter, but it doesn't always. But it always makes the proof more intuitive. You're doing things like simplifications and modus ponens instead of obscure distributions and things like that. And so we use conditional proof when it is useful to build a horseshoe. Again, it could be in the middle of a proof. It could be like this one where the conclusion is a horseshoe. But in general, we use it when we need to build a conditional, and we see that we can make easy inferences if we had the antecedent. So let's go ahead and try let's do one off of the exercise sheet from last unit. So remember, that one was sorted into easy, medium, hard, and very hard. Let's see if it makes one of the very hards easier. So I'm sure you all remembered and loved this one. O hooks Q and N is the case that N or E hooks S. From that it follows if O then S. So if I copied that problem right, if you remember, this was just a kind of mess with distributions and such, and then a hypothetical syllogism. But now imagine we were allowed to use conditional proof on the problem. We did our first step. we looked at the conclusion, we asked, does it occur in its entirety in a single premise? No, which means we have to build it. And so we just ask, well, do I want to use hypothetical syllogism or conditional proof? I simply ask, if I had O as an additional premise, would that help me make some inferences? It's pretty clear that it would. So I'm going to use conditional proof. I'm going to indent because it's an assumption. I do not know O is true. It's an assumption for a conditional proof. Well, now if I'm doing that, I just need to show that this assumption leads to S. This step's optional, by the way. That's just a side note. Well, that's pretty easy now. Well, I get Q and N with lines 1 and 3 modus ponens. How does that help? Because I can get S if I have N. So I com, I simp, I add, I modus ponens. By the way, I didn't have that solution in front of me or anything. It's just what I told you before, that when we use conditional proof, it usually makes the inferences a lot easier. Yes, it might not save a ton of lines, but I mean, we're talking about modus ponens, simplification, and addition instead of really tricky, you have to see how to use distribution in the right way kind of problems. So, what have I shown? It's still indented. I haven't shown this, or this. I've shown exactly one thing, which is that O leads to S. O leads to S using lines 3 through 8, conditional proof. And again, if the proof kept going, I could not refer to any of these ones I just blocked off as part of the assumption because I don't know any of them. All right, let's do another conditional proof. This is, just to kind of emphasize that, this is number 8 on 107. If you remember, we did this one together. It said C or D. C implies X. D implies not Y. Not Y. Or, sorry, it's the case that not Y or X implies not D or Y. Sorry, hooks Y. From all of that, it's supposed to follow that D if and only if not Y. And remember, this is equivalent to if D, then not Y. And if not Y, then D. It's really messy. Sorry about that. So, I know that I'm trying to get this thing you can't read, which was not Y hooks D. I need to get this. Well, come on, autofocus. Come on, autofocus. You can do it. All right, there we go. I need to get this in order to get to my conclusion. So, even though it's not the conclusion, I need to build a conditional. So I just ask, would the assumption of not Y let me make some inferences? Sure would. This is 4. So, line 5, I indent. Because it's an assumption for a conditional proof, I am assuming not Y and trying to show that it leads to D. So let's get started. Well, premise. So notice I have a D in several premises, so I might just start poking around. Usually if I don't have a clear starting point, I start breaking down. But notice not Y doesn't help me with premise 1. Not Y doesn't help me with premise 3. So I'm looking at premise 4. So I just go not Y or X using line 5 addition. And that lets me do a simple modus ponens. And so I get everything after the main operator horseshoe in line 4. You say, wait a minute, I have not y, which means I can do a modus tollens. Careful, the only proper modus tollens you could do with 7 and 5 has to conclude a negation. So in this case, it adds one more tilde, so you get not D, and then that gives me D with line 8, double negation. Okay. That was what I was trying to show with the conditional proof, because I've proved exactly one thing. I've proved that not y leads to D using lines 5 through 9 conditional proof. Now, why in the world did I need that? Well, because that's half of my conclusion. So now the rest is business as usual. I go a conjunction with lines 3 and 10. And that is logically equivalent to my conclusion using my only triple bar rule. So notice, this is still business as usual because I know this now. So I just use this as yet another deduced premise in my proof, which lets me get 11, which lets me get 12. So that's conditional proof in a quick nutshell. So my general rule is if I need to get a conditional, I use conditional proof unless there's obvious hypothetical syllogisms. If I need to get a biconditional that doesn't look too easy, then I use conditional proof twice. So we didn't need to in this because we had the premise 3 there. But if I didn't have something like premise 3, I'd do 2 conditional proofs. I'd assume D and show it leads to not Y. I'd assume not Y and show it leads to D. So that's conditional proof. I will turn you loose to practice. Next time we're doing a rule that is in some ways similar in that it requires assumptions called indirect proof, but we will get to that next week. Between now and then, practice, 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 and then make very sure you're shoring up any weaknesses on the 3.1 and 3.2 material because that stuff will not go away.